okay? The other thing is if you're looking for a lab to do on your own, the sheet I just gave you could help you out along those lines, okay? Remember, actually, under my things you can do on your own, one of the things you can do on your own is take a sky map, just like this. You can take this one and mark it up what you see in the sky. There are some other criteria to turn in for your report, though, so look at that carefully and let me know if you have any questions. The other thing I try to remind students is another thing you can do on your own is actually related to the moon. You have to look at the moon, you get to look at the moon through binoculars or a small telescope and sketch what you see, and that's just one evening thing. So that's actually one of my other things I tell students that are looking for a lab. Well, you need clear skies, but you can definitely get it just by looking at the moon. Okay? So those are two things you can do. Any questions? Okay. Well, we shall continue. Dun, dun, dun. Thank you. Talking about the Jovian planets. Okay? And so, actually, this is where I have us starting. With this seems right. Okay. Filling in the blanks. In order to have weather, you basically need to have an atmosphere. So that rules out Mercury, right? And in order to have weather, you need to have some sort of wind moving around, okay? So actually, all of the Jovian planets have weather to a certain extent. The last planet in our solar system, which of course would be Neptune, has the fastest winds ever clocked in our solar system. Neptune, you're like, really? Yeah. So we talked how the gas giants actually kind of come in twos. We actually have Jupiter and Saturn that kind of have that orangish hue, and then we have Uranus and Neptune, which is kind of blue guys. Okay, let me do the lines a little bit. What makes Jupiter so beautiful, and to a certain extent, its partner Saturn, is actually these sort of compounds that are actually condensing in its atmosphere. So closer to the surface of Jupiter, it's warmer. Okay, and then as you get farther out, it gets cooler. Oh, that's in altitude. I thought that was like degrees Celsius. Yeah. So this is warmer and it gets cooler. Look at the thermometer. So basically you have an assortment of ammonia, ammonium sulfide, water condensing to form that kind of assortment of colors that you see there. I just think that is so cool. So Uranus and Neptune are blue because of the presence of methane. That's got to be on the test there somewhere. It always is, every semester. What makes these blue guys blue, okay? It's methane. And the reason that actually methane forms in their clouds has to do with they are cooler out there than Jupiter and Saturn are. And what methane does, I like this figure because it shows you what methane does is basically it absorbs the red, but it reflects the blue. And so that's why they appear blue. Actually, Friday night out at the observatory, this guy is so good at finding things through the telescope, it's obscene. So anyway, we got to see Uranus through the telescope, and it was this little blue dot, which is wonderful. Okay. So maybe if it's clear Thursday, we'll be able to see Uranus too. So Jupiter's bands, actually, the bands are called belts and zones. So if you want to show that you're really with it, you distinguish between belts and zones, and they go alternating directions, like this is kind of showing you. Okay, the reddish ones are the belts, and the white ones are the bands. And you can almost see, if you have fast-moving clouds going opposite directions, you can almost see that that's havoc for some sort of storms to form. Okay, so you can kind of see these swirls and everything. This is a pretty good figure because down here, I can see on Jupiter, I think we already talked about the Great Red Spot, or it's coming up here in a minute. That is actually the Great Red Spot right there. What creates this movement is the same thing that actually creates movement of air on the Earth, and that's what we call the Coriolis force. So the Coriolis force, this is the Earth here, or CF for Coriolis force. Actually, the Coriolis force is kind of dead near the equator, but it is more accentuated as you go towards the poles. Oh, there it is. So Jupiter's Great Red Spot. So you might see this letter H. On Earth's maps, we of course have H's for highs and L's for lows on Earth's maps, weather maps. So it's just basically a high pressure system that's been there for They know that a dude clear back 300 years ago wrote down in his notebook, because that's why lab notebooks are so important. He wrote down in his lab notebook that he could actually observe this spot. It's pretty cool. So it just keeps going. It's like the Energizer Bunny. Maybe 10 years ago, there used to be a little, this is the great red spot. There was like a little red spot, but it got like gobbled up or broke up. But okay, so this is looking at all of the gaseous planets, kind of what the surface features look like. Not really surface features, but the cloud features. So there's Jupiter. Okay, here's Saturn. Again, you can kind of see the banding features. Okay, there's Uranus. And remember, Uranus is the crazy dude that actually its axis of rotation is basically in the plane of the ecliptic. Okay, and then here we go. This is Neptune, which Neptune, like I said, has the fastest winds in the solar system. The arrow right there is pointing out a feature on Neptune called the Great Dark Spot. And Voyager missions, Voyager 1 and Voyager 2, actually, they are, we believe, out of the solar system now. But as they flew by, they actually got some pictures and sent them back of all the planets, or not all the planets, but. So the Great Dark Spot was a temporary storm. It's gone away now, kind of comes and goes. So the planets are very, very interesting, but also what's very, very interesting, especially if you want to sink your feet into something, are the moons that orbit the planets. So we said that the terrestrial planets don't really have moons per se. I know Earth has one moon, okay? But the gas giants have all sorts of moons, 170 as of the time this was written, okay? So we need to kind of look at their moons as places of interest to visit potentially. So the moons do have geological activity. The moons it's kind of broken up into large moons, medium moons, and small moons. So the large and the medium ones kind of have a little bit of geological activity. It's not like you might think, though. It's not like Earth's geological activity. Okay. So we talked about how, for instance, like Jupiter got all of its moons, and probably early on when Jupiter was forming, Jupiter actually had a kind of a disk of material around Jupiter that Jupiter's moons formed in. Okay, that's accretion around the planet Jupiter. So we'll be looking at some of these moons. Specifically, we'll be looking at the large moons, 4 large moons around Jupiter, each one of them. Kind of put up by size. Down here is our smallest planet, Mercury, our moon, and Pluto. So these are actually kind of drawn to scale. So yeah, you can see that these are large and Pluto is very small. So those are around Jupiter. Okay, these are around Saturn. One of the moons around Saturn we're going to look at is Titan. Okay, these are around Uranus, and these will actually be medium-sized moons. And these are around Neptune. So we'll definitely here in a minute talk about these are the Galilean moons, Titan around Saturn, and Triton around Neptune. So if something's relatively large, like a medium moon or a large moon, actually it has enough gravity to go ahead and round off its edges. So those that we saw, those large and medium moons on the previous slide were nice and rounded. These small moons, not so much. So these actually, these small moons are notorious for going backward in their orbit about the planet, okay, because they might have just been captured. They weren't really part of the accretion process. So I don't know if these small moons kind of look like the moons around Mars, the Phobos and Deimos. Did they show the Martian moons in the movie?
Not really, but I mean, you could see them.
They could sometimes?
They're floating around.
Oh, that's cool. Can't wait. Oh my gosh. Everybody should see it. So those are small. So let's kind of look at, let's go look at each of the Galilean moons around Jupiter, starting with Io. So Io is the pocked planet. Io is the closest of the Galilean moons. So as these slides actually are going to go from the closest Galilean moon outward. So Io is weird in that it actually has these little oh, they call them volcanoes, but they're like almost little openings, like little openings in the planet, in the moon, where actually sulfur-containing compounds spew out. So that's what makes sulfur-containing compounds, makes it yellow. So it's really kind of ugly. So Io is not that big, so you might be like, well, how can it be spewing stuff, which suggests that it's warm in the center, okay? And here's the deal. It's called tidal heating, and we have a lot of tidal things. Tides are created, Earth's ocean tides are created by gravity, right? Okay, so this tidal heating is also created by gravity. So basically what happens is there's times, and I like the top figure up here the best, I think. There's times when Io is close to Jupiter, and when it's close to Jupiter, basically kind of flexes out. And there's times when it is farther from Jupiter, and when it's farther from Jupiter, it kind of relaxes. So it flexes, relaxes, flexes, relaxes. And it's even more complicated, like you see down here, depending upon what its other fellow Galilean moons are doing. But this kind of, if you take a ball and it's called a stress ball. I don't know if they make them anymore. But basically, we should all have one. But basically, if you do this a lot, it gets warm. Okay, and that's exactly what heats Io. It's called tidal heating. So after Io, we have Europa. And the surface of Europa, this is actually, of these, we do have kind of these three up here. These are actually photographs. Sometimes it's hard in your textbook to recognize, is that a photograph or is that a drawing? But these are actually, this is the surface of Europa, okay? And this kind of weird looking circle up here, that is Europa. So you can kind of see the blue hue, and it's really thought that the surface of Europa is like ice. Okay, that's the surface of Europa. Underneath the surface of Europa is liquid water, just like this figure shows you. Yeah, up there. Okay. So there's an icy crust, and underneath it is liquid water. And actually, that's kind of a theme for some of these large moons. Okay, and that's their tectonics. So you're like, that's their gives them geological activity. It's not liquid mantle; it's liquid water underneath the crust. Okay, that's it. So that's Europa. Then I have Ganymede and Callisto together. Ganymede and Callisto, they're kind of like Europa. It looks like they have an ice crust with possible water, liquid water underneath it. So these are photographs. These are large moons that orbit Jupiter. Pretty darn cool. So actually, the topic of the Skype meeting on Wednesday is something like this. It's sponsored by Phi Theta Kappa, and what they wanted to ask Dr. Green is, so NASA, this whole idea of sending these space probes, which are unmanned, to the farthest reaches of our solar system, what's in it for man? That is basically, it's kind of a challenging question. So I would say there's a lot in it for men, but we'll have to see what Dr. Green says. And again, he was a consultant for the Martian movie. All right, so those were the Galilean moons. Now we're switching gears to Saturn, and a large moon around Saturn is Titan. Now, don't blame me, because here in a minute when we finish up with Neptune, Neptune's largest moon of interest is called Triton. I hate it. So Titan, Titan, and Triton, Triton. I wonder where that's where like the red dwarf guy his name came from. Okay, so Triton actually has been visited. Dun, dun, dun. Okay, the spacecraft that visited it was Huygens. Okay, it's not sending back any data now. Somebody came and turned it off. I'm just kidding. Okay. But actually, this is what it saw when it landed. Okay. It is pretty darn cold out there. But like the slide says, because it's actually got substantial atmosphere, can you kind of see the haze around it? That's a photograph of Titan. And that haze is actually its atmosphere. So cool. So the exciting thing about it being just chock full of methane, which is a greenhouse gas, gives it a little bit of warming, is that methane, NH3, actually could be a precursor to a lot of our amino acids that for life. Okay, so you're like, oh. you know what I'm saying? So the thing about Titan too is they pulled all of the information, all of the observations to suggest that actually it has a liquid cycle, but it doesn't rain water, it actually rains methane. Okay, NH3 methane here on Earth actually is a gas, but when it's cold over there, it's a liquid. Okay, so it actually rains methane, so there are actually lakes of methane there. It is just amazing.
Is that bad for us, like if we just started raining methane?
Methane, we actually can burn methane as a fuel, but yeah, I think it would be bad. But you know, life could adapt, right? I don't know. It's
We
interesting.
wear helmets every day and stuff.
Yeah. I can tell you just came back from seeing The Martian. I think it's really interesting too. Okay, so Titan is around Saturn. So these are, Titan would be considered large, right? These are an assortment of medium moons, medium-sized moons around Saturn. Okay, down there at the bottom, Enceladus. Actually, Enceladus has been in the news. Enceladus is an awesome sort of moon in that it actually has these geysers that it opens up and it spews what starts out as liquid water, just kind of look like liquid water under Europa, and it spews it up into the air, and then it basically it's like snowfall. It falls back to the. It's just beautiful, Enceladus. So this actually is Iapetus. Easy for you to say. So Iapetus and Enceladus. So I told you Enceladus is so cool about the liquid water coming out, and so actually caught in the action here are some of that, the liquid water spewing out, and you can see it would crystallize and fall back to the moon surface. So that Friday night when there was public viewing at the observatory, not only did I see Uranus, but I saw Saturn for a little bit before it's kind of low in the horizon these days. But if you ever get a chance to look at Saturn through a telescope, a lot of times the operator will say, well, there's the moons of Saturn. And I know that the operator said, yep. Dave's like, that's Iapetus. I'm like, oh, that's cool. Okay, so actually, I just think it's neat to be able to see these planets and these moons. All right, so moons around Uranus and Neptune. So around Uranus, we have a picture here of Miranda. And I'm thinking this is the right one. It's actually kind of famous in that it looks like a Frankenstein moon, in that it looks like it was kind of fragmented, but basically little fragments have kind of come together to make the moon. And here is Triton. Ugh. Titan and Triton. Not only do they start with the same first letter, okay, but they actually sound alike. So Triton, and actually this isn't just this textbook. It's notorious for having kind of a surface feature they akin to like a cantaloupe. It really does look like a cantaloupe. I personally don't like cantaloupe, okay, but it's Triton. So Triton is weird, and sometimes I've included this there's a homework question I don't think I picked for this semester, but Triton actually goes around its planet backwards. Okay, so the fact that instead of going counterclockwise, the fact that it goes clockwise and the planet spins counterclockwise, that suggests that actually probably it was captured. It wasn't created out of like an accretion disk around the planet. And it's probably going to run into the planet one of these days. So kind of side by side, we can talk about, I know they seem weird, but we can talk about our inner terrestrial planets. We can compare those to the large and medium moons that we just saw. Okay? The moons that we just saw, you can, by golly, step on them. Although what you're stepping on is probably like crunchy ice. Okay? Some of the terrestrial planets, specifically Earth and Venus, are actually ooey gooey underneath. You know, Earth has plate tectonics, and Venus has this sort of weird kind of resurfacing its whole surface every 750,000 years or something like that. But also, those large and medium moons also have liquid water underneath them, underneath the crust. So there are some similarities there. All right, let's talk rings. All of the gas giants have rings. So actually that is Jupiter, okay? And there's Saturn. Can you see the rings? There's Uranus, and there's Neptune. So they all have rings. It's possible, I don't know if I'll convince you about this, but bless you. I think the last slide kind of talks about actually Saturn's rings could over time kind of go away. So just kind of where we are at the right spot at the right time. So those rings are not solid. You couldn't go and pick up the planet by the rings. By the way, Galileo thought that actually it looked like Saturn had ears. I think that is funny. So I'm going to show you a picture here, an artist's rendition of what the rings look like. They're actually little tiny particles. So this kind of shows you, perhaps, kind of from left to right, the progression of how the rings formed. So this first figure over here on the left, you can see actually if we call this Saturn, okay? And actually Saturn, at this point, over here on the left, doesn't have rings per se. Instead it has moons. Okay, those moons can eventually kind of run into each other, okay? Or get, this says that something outside can actually impact them. They break up, okay? Then instead of having one object orbiting the planet, basically you have several objects orbiting the planet. And they can actually kind of run into each other, make each other smaller, and kind of fill out that orbit. So that's how you get these rings. So Saturn's rings, kind of these first two pictures are actually photographs. And the last one is showing you kind of an artist's rendition of what the material in the rings would look like. I've heard NASA kind of toy with kind of putting a probe in the rings or through the rings. But that's problematic because, for obvious reasons, it could get really banged up. So the rings themselves are only about 30 feet thick, and they're very reflective because actually they have a lot of icy component in them. So we're not going to emphasize it this semester, but actually this is Saturn's rings over here on the far right, and they actually have names. Like there's the F ring, the E ring, the A ring, the B ring. There are gaps. There's a big gap called the Inky Gap. And the gaps are created by moons, either just because of the gravity of the moon or the moon literally clears out a spot. Wow, we did that fast. So I'm not going to start the next part. Actually, I think we're going to be in good shape. What I want to do is probably Wednesday, I want to show you, I think, a movie on the leftovers of our solar system, which would be the asteroids, the comets, okay, that sort of thing. Okay? That's all I got.